Hi everyone, welcome back to the network trip. Today I'm bringing you breaking news from MikroTik. They have just added support for EVPN in the latest RouterOS 7.20 Beta 2. This is a big step forward for data center, service provider, and cloud fabric use cases. But a quick and important disclaimer. This feature is still in beta, so you should only use it in a lab environment. Don't even think about deploying this in production yet. Things could change fast and unexpected behavior may still appear. In this tutorial, we are going to test this exciting new feature by building a Spine-Leaf topology. This is a modern network design used in large-scale environments like data centers, for example. Here is how the topology works. We'll use OSPF as our underlying routing protocol to ensure full IP connectivity between all routers. Then on top of that, we'll run iBGP to carry EVPN routes, which will manage our VXLAN tunnels. What about the logic? What exactly is this spine-and-leaf architecture? The leaf routers are where the end devices connect, like PCs, servers, VMs. These leaf routers act as VXLAN tunnel endpoints, or VTEPs. That means that they encapsulate and decapsulate traffic into VXLAN packets. These spine routers are at the core. Their job is simple: to route packets across the underlay using OSPF. And they will act as a BGP route reflectors, so that the leaf don't need to form a full mesh. All the traffic between VLANs, like in our topology, VLAN 100 and VLAN 101, will ride over the VXLAN overlay, and EVPN will make sure that each leaf knows where to send traffic for remote MAC addresses. Now that you understand the logic behind this design, let's jump directly into the RouterOS configuration. I walk you step by step through setting up OSPF, BGP, VXLAN interfaces, EVPN route targets, and bridge mapping. We'll also test connectivity across the overlay to make sure that devices in VLAN 100 and VLAN 101 can talk across different leaves using VXLAN tunnels managed by EVPN. Let's get to work. We are ready to start the configuration. And the first step is going to be to add the IP addresses to every physical interface, and additionally, the loopback IP. This IP is going to be critical because all the BGP sessions will be established by using that IP. For the sake of time, I have already configured all the IP addresses as per the network diagram. So we go, for example, to Spine 1. So we're going to see those three interfaces connected to the leaf 1, 2, and 3. So the networks 10.1.1, 10.1.2, 10.1.3. So the second octet is the number of the spine, and the third octet is the number of the leaf. The spine is going to use the first usable IP, in this case .1, and the leaf the second one, .2. So let's see, for example, the spine 1. So if I come to the spine 1, IP addresses, so we can see here the link going to leaf 1, to leaf 2, leaf 3. And then we have the loopback IP. So the loopback IPs are here in the diagram. So you can check that information here. So remember, you can download the diagram from the description. So you'll find a link in there and you can have access to exactly the same diagram that I'm using here in this video. If I go to any of the leaf devices, for example, this is leaf 1, I can check the IPs. And basically, we have an IP on Ether 1, an IP on Ether 2. This is connected to the spine 1, this is connected to a spine 2, and then we have the loopback IP. Notice that the leaf devices will have 10.254.254. And then the ID of the leaf, in this case 1. And that is on the interface LO or loopback. So that's basically the step number 1. Pretty straightforward, just adding the IPs to the physical interfaces and the loopback IPs. So the next step is to configure OSPF. So we need to have the routing domain. So that is going to be between the spine and leaf devices. OSPF is going to be the routing protocol that we are going to use for the underlay. So we'll start with the configuration on spine 1. So we'll come here to the spine 1, and I will go to routing, then OSPF. And then here we are going to need 3 different things. So the first one is the instance, then we're going to need an area, and then the interface templates. So if I go to instances, I can simply create an OSPF instance. I'm going to call it OSPF IPv4. And then the router ID is going to be the IP that is on the loopback interface. So in this case, 10.255.255.1. We'll need an area, so we'll have a single area in this topology, and that's going to be the area 0. So we leave the area ID with all zeros. And then here on interface templates, we are going to need 2 entries. One entry that will be for point-to-point connections. So those links will be expecting neighbors. In our case, Ether 1, Ether 2, and Ether 3 are expecting an OSPF neighbor. So this is going to be one interface template containing those 3 interfaces. So let's go back to Spine 1. So I will add this interface template, and then I will add Ether 1, Ether 2, and Ether 3. Area is area 0, and the network type is going to be point-to-point. So we don't need to add security or any of those advanced settings in here. So if you want to get more insights about that configuration, check the series related to OSPF here in the channel. So now I can click OK, and this device is expecting 3 adjacencies out of Ether 1, 2, and 3. And the next step is to advertise the loopback IP. And to that, we need a second interface template, and we're going to pick the LO interface. But in this case, it's going to be passive. So passive means that we are going to advertise the IP information that is on LO, that is the loopback IP, but we're not expecting any OSPF neighbors out of that interface. And I can click OK. And we have the OSPF configuration ready. Obviously, at this point, we don't have any neighbors because we have to configure the rest of devices. So what I'm going to do is that I'm going to extract the OSPF config. I can simply go here to routing, OSPF, and then I can say export compact, and I will copy all this configuration into a text file. And then I can simply make the changes before applying this configuration in the other devices. So that is going to increase the speed for adding that configuration. So I'm going to use VS Code, and I will simply have this file, spine1.rsc, and I will have a comment here, OSPF. Also, these files will be available in a link in the description of the video. So we have that for the Spine 1. Now we're going to create another file that's going to be spine2.rsc. And I will simply paste that in here and we'll make some changes. So in this case, this is for the Spine 2. So the router ID is going to be different. And then the area, this is going to be the same. So we don't need to make any changes in here. And then for the interface template, so we check the diagram. So the Spine 2 also using Ether 1, Ether 2, and Ether 3. So we don't need to make any changes to that entry. And also we don't need to make any changes to the loopback interface. Now we can simply copy this configuration and we can go to the Spine 2 and we're going to paste that in. So just to validate, we'll go to OSPF. We can see the instance here with the correct router ID. We can see the area and also the interface template with the appropriate interfaces. So we have OSPF ready on the Spine devices. So we'll do the same with the Leaf 1, 2, and 3. So in this case, the Leaf 1 is only expecting a neighbor on Ether 1 and Ether 2. And also we are going to advertise the loopback IP. So we'll create another file. And I will simply copy that information here. For the Leaf 1, so the router ID is going to be 10.254.254.1. Then the area is going to be the same. And here we are expecting 2 neighbors. And those will be out of Ether 1 and Ether 2. And also we are going to add the LO interface as passive. So everything looks fine in here. So I can simply copy that. And I'm going to paste that in the configuration of this Leaf 1. So now here at Leaf 1, we have added the configuration. And then if I come to routing OSPF, we see the instance, we see the area, and we see the interface templates. And now I'm expecting to see two neighbors. And actually we can see here the two neighbors. So we have an adjacency going to spine 1 and another adjacency going to spine 2. Then we can repeat this process. So now I will simply copy that file. And now it's going to be leaf 2. And we'll copy that file again. And this is going to be leaf 3. So we'll modify the leaf 2. The only difference here is the router ID. So now it's 10.254.254.2. Everything else remained the same. And it's exactly the same because the way how the topology is built. So we see that we are using the same interfaces. And the only difference here is going to be the router ID. So now we can go to the leaf number 2. We can paste that in. And if we go to OSPF, we see the instances, we see the area, we see the interface template, and also we can see here the two neighbors. And finally, we'll do the same with the leaf 3. So in this case, the router ID is going to be 10.254.254.3. And again, we are going to copy all of this, and we'll go to the leaf 3. And now let's go to routing, OSPF. We see one adjacency, and we have the second adjacency, spine 1, spine 2, and also the correct router ID. So at this point, we should be able to ping all over across our topology. So from the leaf 3, we're going to ping the spine 1. So we see that we have connectivity. We're going to ping the spine 2. Perfect. We're going to ping the leaf number 1 working, and also the leaf number 2. And we can source this from the IP on the loopback just to check connectivity. So now we have full IP connectivity. So in all this area here, OSPF is doing the job, and we have full reachability between all the loopback interfaces. So that's one requirement to be successful on this lab. So the next step is to create a bridge interface, and that is going to contain all the interfaces that are facing the clients. So in this case, the client will be servers or computers or any type of device that will be in those VLANs that we're trying to extend across our topology. So we see our diagram. So basically here, on every leaf, we have Ether 3 and 4 that are connected to those devices. So we're going to create a bridge here, and we're going to put those interfaces. Ether 3 will belong to the VLAN 100, and Ether 4 will belong to the VLAN 101. We see that we have exactly the same interfaces, the same VLAN IDs. So we are going to configure manually the first leaf, and then we can simply copy and paste the configuration on the leaf 2 and 3. So let's do that. So let's go now to the leaf number 1. And then here we are simply going to create a bridge. So we're going to keep the default name, bridge 1. And then we are going to enable VLAN filtering. So we'll require VLAN filtering just to allow the traffic that we are intended to have in this topology. And then we'll add the ports. So we have 2 ports. So we have the first one that is Ether 3. So this is an access port for VLAN 100. So I'm going to type here the per VLAN identifier 100. And here I'm only expecting on tag traffic. So on frame types, I'm going to say admit only on tag traffic. And I click OK. And then I'm going to do the same for Ether 4. But in this case, the VLAN identifier is going to be 101. And also I'm only expecting on tag traffic. So we are ready. So we have the bridge, we have enabled VLAN filtering, we have the 2 ports with the correct PV ID. So now we are ready to export the configuration. So here we simply go to interface bridge and then export compact. And now we can take that bridge configuration. So it is under the leaf 1. So we'll go to our file here and then leaf 1. And we can create a new section. This is going to be the bridge. And we can simply paste that information here. So we see that this is basically the same for all the leaf devices. So I will simply copy that into leaf 2 and also leaf 3. And now I can go to the terminal to those two devices and paste that in. So let's start with the leaf number 2. So we have that in here, paste, ready. We'll check the config. So we have 3 and 4, and we have the bridge created. And then we're gonna do the same on the leaf number 3. We're gonna paste that in. And now we check the bridge. We have 2 ports with the correct per VLAN identifier. So that means that the step number 3, it's done. Up to this point, we have been building blocks that are creating the underlay that will be required to have VXLAN-EVPN working correctly. And that's exactly the next step. So in the overlay, we are going to be using VXLAN. So we'll have EVPN and VXLAN working together. So VXLAN is going to encapsulate those Ethernet frames, and they will be sent to the other end of the tunnel. And then they will be de-encapsulated, and that will allow that communication in layer 2. So this is one of the technologies. So this video is about VXLAN EVPN. There are other technologies, like for example, using MPLS or VPLS, but in this case, we are simply going to use VXLAN EVPN. So we need interfaces for that, and that is going to be on the leaf devices. So we are going to start with the leaf number 1. So there are some fields that we need to configure. So I'm going to explain why we are going to configure those, and then we'll see that in action. So let's go to the leaf number 1. So we'll close all of these, and here we'll simply go to interfaces, and then if we go to VXLAN, so there is nothing here now, so we need a new interface. So here there are different ways to configure VXLAN. So one is having a single VXLAN and send multiple VLANs through it. Or the second option is to have a VXLAN interface for VLAN. So on this video, I'm going to have 2 VXLAN interfaces, one for VLAN 100 and the other for VLAN 101. So there are some fields that are quite important. So the first one is the VNI. So this is an identifier. So we have 24 bits, around 16 million different IDs. So that's a lot more than just the regular number of available VLAN IDs. So in my case, I'm going to use an identifier, something like 1100. So this is basically the VLAN ID. So if I see this number, I know, okay, this VXLAN interface is going to be used by VLAN 100. And also I will put this DNI on the name. This is not required, but just for the sake of simplicity, I like to have the name matching the VNI. So this is one of the fields that will be required. Then also we are going to need the local address, and we are going to have some sort of tunnels that will be created dynamically. And those will be using an IP. And that IP is going to be the IP that we are using as a router ID and the one that we have in the loopback interface. So on this device, that is 10.254.254.1. So I'm going to put that value in here. And then if we go down, we have the bridge. And then here on the bridge, we're going to select the one that we have created. And then the per VLAN identifier, I'm going to set 100. And also, we don't need to learn that in here because we're going to use BGP and EVPN to do that later. So we are going to disable the learning on this VXLAN interface. So the per VLAN identifier 100. So when this interface gets created, after clicking apply, so this interface will be added to the bridge, and then the PVID is going to be 100. So now I can simply click apply. And if I go to the bridge, we are going to see that we have a new dynamic interface that has been added to that bridge, and that is called VXLAN 1100. And the PVID is 100. So if I go back to VXLAN, I will simply copy that. But now I need to create a new one, but this is going to be 1101. So I will modify the name. The local address is going to be the same. And the only thing that will change here is the VNI. And also we are going to change the per VLAN identifier to 101. Now I can click OK. So I have 2 different interfaces. So we see that this MAC has been generated dynamically, B0. And also here we see that this got the same MAC address, so I will disable it and I will apply. Now we are getting a different MAC address. So just to be careful, we probably would like to have different MAC addresses to avoid any type of conflict later. Okay, so now the configuration on leaf 2 and 3 will be pretty similar, but we don't want to have a hard-coded MAC address or the same local address. So we have to match that to the loopback IP. So I'm going to extract the configuration under interface VXLAN. So I'm going to use export compact, and I will simply copy all these commands and I will paste those in my code files. So I'm going to go to the leaf 1 and I will create a section here called VXLAN. I will paste that in. So this is going to be like this on the leaf 1, but then I'm going to go to the second file, leaf 2, and here I need to change the local address. So it's going to end in .2. And I don't need this MAC address in here. And now I can copy that into the terminal on the leaf number 2. So this is the leaf 2 terminal, paste that in. And now we have those two VXLAN interfaces with the correct values. So we have the VNI, we have the PVID, and also the correct local address. And the next one is going to be to go to the leaf 3 file. And here we're going to change the local address to .3, and we no longer have the MAC addresses in here. So I can simply copy and paste that in the leaf 3 terminal. So we have that in here, enter. And if we go to interfaces, VXLAN, you see here that we have those interfaces, and also they are part of the bridge now with the correct per VLAN identifier. So the next one is going to be the step 5. Here we are going to configure BGP peering. So BGP will be configured on the spine and also the leaf devices. But we won't have a full mesh. We're going to be using route reflector. If we go back to the topology, so we have here these spine devices, and we have all the leaf devices. So the spine devices will be working as a route reflectors. And then we're going to have a session between every leaf to every spine. So every leaf will have an iBGP session to every spine. In my case, I'm going to be using the same autonomous system number. So that is going to be iBGP. But this also works if you are using different autonomous systems. So in that case, you will be using eBGP. And in that case, you don't need route reflectors. But in my case, I'm going to be using iBGP because I'm going to be using the same autonomous system number. So I must use route reflectors to be able to advertise the information correctly. So that means that in the future, if I add more leaf devices, they will simply peer to those spines. So we don't need full mesh between all the leaf devices. If I don't use route reflectors, I will need full mesh between the leaf devices. So obviously that is not scalable. So it's better to use route reflectors. And in this case, we're going to have two route reflectors because we have two spine devices. So that's basically the approach here. Starting with RouterOS 7.20, there are multiple changes to the BGP section. Like, for example, now we have the instances menu. So let's see here on this device, routing BGP. So we see this instances menu. So when we're creating the connection with the prior releases, all the entries with the same router ID were mapped to the same instance. But now that is no longer the case because we have this instance field here that we need to provide. And we have this instances menu. The second change is that if I check the connections under address family, we still don't see the EVPN family. So that means that some of the configuration can be completed using the Winbox, but some of the configuration must be done using the CLI. So if I go to a terminal, for example, and then I go here to routing, BGP, and connections, and then I add a new entry. So we'll see here that we have the address family. So here we can see more address families than the ones that are displayed here in the Winbox. So we have EVPN that is not available in here. So we can complete some config here in the Winbox, and that's exactly what I'm going to do. And then we'll jump to the CLI just to add the address family. So first thing that we are going to need is the instances. So on the instances, we're going to give it a name. So this name is completely up to you. But in my case, I'm going to be using EVPN-BGP. Something else that we're going to need here is the router ID. So I'm going to set the IP in the loopback interface as the router ID. And then the autonomous system number, I'm going to be using 65001. So basically, that's all the information. Now we have the BGP instance. So you see that the autonomous system number has disappeared from here. But if I go back to the terminal and I type routing BGP instance and then print detail, we see that that value is still here. This is kind of a bug in Winbox. So the value is actually there, 65,001. Okay, so we have the instance ready. So the next step is to add the connection. So for the connection, so we are now on the spine 1. So it's going to have 3 connections. 1 connection to every leaf. And they will be iBGP. And the role for this one is going to be route reflector. So we'll add that information now. So let's go to the spine 1, and I will add the first entry. So this is going to be iBGP going to leaf 1. And then we pick the instance, EVPN BGP. We don't need to give the autonomous system or the router ID again, because that is going to come from the instance configuration. For the remote address, we'll be using the loopback IPs. So for the leaf 1 is 10.254.254.1. And the remote autonomous system is going to be the same than the one on this device because we are using internal BGP. And then the local address is going to be the loopback on this spine 1. And the local role for this device is iBGP route reflector. And then we'll enable connect and listen. So we don't need multi-hop because in this case, this is iBGP. So multi-hop is required only for eBGP. So the next thing that we're missing here is the address family, but we don't see here EVPN. So I won't do that now, and we're gonna add that setting through the CLI. So now I can simply click apply, and this is gonna be the leaf 1 here on the name. And now I can simply copy that configuration, and I can simply say now for the next one, iBGP leaf 2, and the remote address in this case is gonna be 2. Then all the remaining fields will be the same. So now I can apply the changes and I can go to the leaf 3. And here this is going to be 3. Everything else is the same. So now we have the 3 connections that we are expecting on this spine 1. But we are missing the address family because that is not available on the Winbox. So let's go back to the terminal. So here on the terminal, we'll simply go to routing, BGP connections. We can print, and basically we are going to get the same information that we see here on the Winbox, but we don't see anything about the other family because we didn't add that information. So now I can simply say set, and we are going to set the other family, and we are going to pick EVPN. So that value in there. And then we need to apply that to every entry in that section. And to that, we are simply use the square brackets and find. So basically, it's going to loop through every entry. It's going to return the entry. And then this change is going to be applied to every entry. So now if I press enter and then I print again, so we can see every connection, but now the other family is set to EVPN. So basically, that's what we want. So we are ready with VGP on this spine 1. So I can export that config. So I'm going to go to routing BGP, export compact. And now I'm going to take all this configuration and I'm going to paste that into my file here for spine 1. And this is going to be the BGP section. So now I can simply take that configuration and paste that into the spine 2. The only difference is going to be the loopback IP, because now that is going to be the spine 2's loopback IP. So that is going to be the new router ID. So I can go back to the code here, and we're going to modify it. So the router ID for this one is going to be 10.255.255.2. And then for every connection, we're going to change the local address. So now we'll copy that and we can go back to the Spine-2 device and we'll simply paste that in here. So now we have that and we can check it. So print detail. And now we see that we have all the connections that we're expecting on this Spine-2. Okay, so now we can jump to the Leaf devices. So we have 3 of them. The configuration here is going to be a little bit different because these devices won't be an iBGP route reflector. It will be simply iBGP peers. So the Leaf 1, for example, is going to have a peering with the Spine 1 and also going to have another one to Spine 2. So this is the Leaf 1. So we'll go to routing BGP. So we'll start again with the instance. So it's going to be called EVPN BGP. The router ID is 10.254.254.1 and the autonomous system 65001. So we have the instance. Now we'll add 1 connection per spine. So the first one, iBGP spine 1. And then the remote address is the loopback in that spine 1 that is that IP here. And the remote AS 65001. Local address, the local loopback IP is going to be that one. The local role is iBGP and will enable connect and listen. We apply these changes and now we can simply copy that and this will be pointing to the spine 2. So router ID is the same. The remote address, now this is going to be .2. Everything else is the same. So now I have those 2 entries. Again, we are missing the other family. So I need to set that value. So now we can go to routing, BGP, connections. We can print that. We don't see anything related to address family. So we are going to set the address family equals to EVPN to every entry. Square brackets, fine. And now if I print that again, so now we can see that we have the address family that had been set. Additionally, at this point, that session should be established. So if I go to session and I print that, so we can see that we have 2 established sessions here, going to the spine 2 and going to the spine 1. Also, we can check that in the Winbox. So if I go to sessions, so you see those 2 entries here with the E. So that E means established. So we are in good track. So the configuration for Leaf 2 and 3 will be pretty similar because they will have the same number of sessions. And again, the only difference is going to be the local address because we have to match the local loopback IP address. So we're going to export the configuration on Leaf 1. So routing, BGP, and then export compact. And I will simply copy that configuration into my code files here. So this is the Leaf 1. So I'll add a new section. This is going to be BGP. And I will paste that in here. And now we can simply use that information on the Leaf 2 and also on the Leaf 3. So we'll start with the Leaf 2. So here we have the routing BGP instance. So the router ID for the 2 is going to be ending with .2. And then for the connection, we're going to change the local address to .2. Everything else remains the same. So now I can simply copy that and I can jump to the Leaf 2 to the terminal, paste that in. And if I check the sessions, now I have 2 sessions that have been established here as well. So we can check it in the Winbox, routing, BGP sessions. So we have 2 established sessions in here. So the next one is going to be the Leaf 3. So we'll go to the file for Leaf 3 and we'll modify the router ID. So it's going to be ending with .3 and also the local address in those entries. So we'll copy the configuration. Now we'll simply go to the Leaf 3, new terminal, paste that in, and we check the session, print, and we have 2 established sessions. So we have iBGP between every single leaf going to every single spine. We are using the EVPN family. So basically, those BGP sessions are ready to start exchanging information and then allow the layer 2 communication between those servers that we have on VLAN 100 and VLAN 101. But we're still missing one important step. This is the actual EVPN configuration. So this configuration will be completed only on the Leaf devices. There are some fields that are required, and we need to talk about it before going to the actual configuration commands. Under VGP, we are going to have an EVPN section. So now that section is visible only on the CLI. In the future, most likely that is also going to be available through the Winbox. But now we are going to find that only through the CLI. So when adding entries under BGP EVPN, we are going to need to know about route distinguisher. So route distinguisher is simply a 64-bit number that will be attached to the addresses that are going to be exchanged. This is going to help to differentiate addresses from one customer to the other, because they could be using the same addresses, but this route distinguisher is going to be unique. A common practice is to use the autonomous system number and then column followed by the VNI. I'm going to be using two route distinguishers. So one is going to be 65,001, 1,100, and the other one is going to be 60,001, column 1,101. So basically to map each of those VLANs that we are using and also to VNIs that we have in place. We need to talk about route targets. And basically we can export route information or we can import route information. So we have set the route distinguisher to those addresses, and now we have something unique for every customer. And basically from that device, from one leaf, we can export the information that we are getting locally. But also we can import the information from other Leaf devices. And we are going to use import and export to get that. So in our case, we are going to be using those RDs or route distinguishers. So we are simply going to export those, and also we are going to import the same values. And that is going to allow the correct exchange of that information. It's important to note that according to the MikroTik documentation, if we are using just one VLAN, we don't need to specify that value because that is going to be auto-calculated by RouterOS. But in my case, I'm going to be using two VLANs, so I need to specify that value to make the difference between those two separate set of addresses that will be exchanging. Now it's time to go back to the devices. This configuration must be done on the CLI because there is no EVPN menu available inside the Winbox at this point. So I'm going to go to the leaf number 1. And if I come here to routing BGP, so you see all the tabs at the top. There is nothing about EVPN. If I go to a terminal and I type routing BGP, and then I press tab in here, so you see here that I have this menu EVPN. Currently, if I print this, you see that this is empty. So we're going to need two entries, one per VNI. So I'm going to add the first one. I will simply type add. And then if I press tab, this is going to show me all the available options that I have here. So the most important one that I need are the export route targets, the import route targets. And also here we can set a name for that entry. We need the VNI and also the BGP instance that we are going to be using. So let's start with the instance. So I'm going to use the EVPN BGP. I'm going to give it a name. So it's going to be EVPN for that VNI 1100. And then for export route targets. So here we're going to use the autonomous system number that is 65,001 and then column and the VNI. So basically that value. And then for import, we are going to use something similar, 65,001, 1,100. And then we need the actual VNI that is 1,100. And now we can press enter if I print that. So we can see here that we have that information here in place. So now we need a second entry, and that is going to be for 101. And this is going to be the VNI 101. And also for export route targets, we are going to modify that route distinguisher, and the name also going to be matching the 101 entry. So now I can print that, And we see that we have the route target for 1100 and 1101 and matching the correct VNIs. So we are basically ready here. The configuration for the leaf 2 and 3 will be exactly the same. So that means that we can simply go back to routing BGP EVPN and we can export these commands. So I will simply copy that and I will go to the leaf 1 here and I will add this section that is going to be called EVPN. And I will paste that in. So we have those commands in there. I can simply copy that into the leaf 2 file and also into the leaf 3 file. And now I can go to those two devices and I will simply paste that in. So let's go to the leaf number 2. And then the leaf number 3. So we have completed the 6 steps that are required to have EVPN working. We are ready to test the connectivity. So what I'm going to do is that my laptop, so this laptop here, will be connected to Ether 3 on the leaf 1. And a second laptop that I have here on the desk will be connected to the Ether 3 on the leaf 2. So I'm going to use the VLAN 100. So the IP on my laptop is going to be ending in .100. So it's going to be 10.100.100.100. And the second device is going to be 101. So if I check the configuration here on my Ethernet interface, so we can see that I have the IP 10.100.100.100, 24 bits in the mask. And then on the other device, so we can see here that we have 10.100.100.101 and 24 bits for the mask. So we see that the MAC address on this one is ending in 90D6. And on my laptop, so we can check the Ethernet interface. So this is ending on 0B11. And it has the IP 10.100.100.100/24. From here, I will ping 10.100.100.101. And then we are going to see that we have IP connectivity. And if I check the ARP table, we are going to see the MAC address directly from that interface. So we see that device, and we see that this is ending with 90D6. And the same is going to happen on the other device. So now I'm going to jump to the other device, and I will ping 10.100.100.100. And we have full IP connectivity. So now if we check, for example, on the leaf number 1, so we see that cable connected here on Ether 3. And if I come to the terminal and I go to routing and then route, and we print that output, we're going to see some interesting information. So I'm going to decrease the size of this just to get everything, and also I will add detail. So we go all the way down in the table. We're going to see some entries like, for example, we can see this MAC IP. You can see here 90D6. So this is the IP that has the second laptop. And then somewhere here we have the 0B11. So this is the IP on my laptop. So you see that this is connected to the leaf 1 and this is connected to the leaf 2. And we have IP connectivity between those two devices. Now what I'm going to do is that I'm going to move my PC to Ether 4 and the second laptop to Ether 4, and we'll simply change the second and third octet from 100 to 101, and then we'll test the connectivity in the VLAN 101. So I'm going to come to my interface here, and I will simply change that IP. So we'll have 101 and 101. And then the same for the other device. Now from my laptop, I will ping 10, 101, 101, 101. And we see that we have connectivity. And then if I go to the other device, from here I will ping 10, 101, 101.100. That's my laptop. And also we have full IP connectivity. So this is awesome. So MikroTik has done it again, has introduced EVPN. So we are testing this in a Spine-Leaf topology. In the next video, I'm going to explore how to do it in a service provider environment. So we can use a slightly different topology. But this is something that could work in a data center. So we'll go with some verification commands. Like for example, we're going to go to routing, then route. And then here we can print some information. So let's see what we're going to get. So we're going to see here that we have a lot of EVPN entries. So you see here the IMET, and then we see the IPs of those Leaf devices. So we see the 3 Leaf devices, and also we see here the MAC of one of the laptops, and I have the MAC of the second laptop. So this is my laptop, and this is the second laptop that I have here on the desk. And now we can see that this is on the device Leaf 1, and this is on the Leaf 2. So this information is going to be exchanged by BGP. So it's going to be sent across those sections, and that's how we are getting that connectivity. And then if I go to the Leaf 1, so I'm going to remove detail from here. So routing, route, print. Also, we see here that information. So we have that EVPN information, and then we have the MAC. So this is a connected MAC here on the Ether 4 now, because now we are on the VLAN 101. If I check the host table, so on Ether 4, so you see here the 0V11. So this is the MAC of this device. And still we have connectivity going to the other device. And if I go to the Leaf number 2, so here we have also on Ether 4, the second laptop. So we can check routing, route, and then print. So we're going to have some similar information. So we see the 0V11, and here we have the local MAC 96. And also we check the host table on Ether 4. We are going to see that MAC over here. Okay, so we have a fully working topology, VXLAN and EVPN in MikroTik RouterOS 7.20 Beta 2. Remember to use this just for labbing. Don't use this in production yet. We're going to wait for a stable release that is going to come, I hope that pretty soon. I hope that this video has been informative for you, and I see you on the next one.